Alright, the question says let g be a continuous function with g of 2 equaling 5. The graph of the piecewise linear function, the derivative of g, shown above for the closed interval of -3 to 7. So part A says find the coordinate of all points of inflection of the graph of y equals g of x for the closed interval of -3x to 7. So to find that, okay, so this, when you find this, use the graph, and any place where you take the slope, the tangent line, slope of the tangent line, equaling 0, that's where an inflection point would be. So whenever the second derivative of g of x equals 0. So that would be at maximum and minimum, so that would be here and here. So x equals 1 and 4 are inflection points. So part B, find the absolute maximum value of g on the intervals -3 to less than x to 7. Justify your answer. So x equals 2 is a possible inflection point. Because, okay, this is the graph of the first derivative. It goes from positive to negative at x equals 2, which is the first derivative test for critical points. And because it is a closed interval, which you tell by this, it's, yeah, greater than or the endpoints are also included. So -3 or 7. But to find the absolute maximum, you have to solve of g of whatever to find which one is the largest. So they give us g of 2 equals 5. To find g of -3, you basically sort of find the area of this. So it would be g of 2 plus the integral of -3 to 2 g prime of x dx, which is 5, and then reversing the limits of integration, because this one's less than this one. So minus brackets, and this would be 4 times 1, 2, 1/2, which is the area of a triangle, plus 1, 2, 3, 1/2 times 1/2 over 1. So now you would have 5, these cancel out, so that's 4. So, and this would be negative, I'm sorry, because going at the bottom, plus 4, close bracket, minus 3 over 2, and that just gives you 5 over 2. So to find g of 7, it's basically the same thing. So you use this area to find it, which would equal g of 2 plus the integral from 7 to 2 g of x dx. So it's 5 plus 1, 2, 3, 4, -4, 1/2 times 2 plus 1/2, 1 times 1. And that would give you 5 minus 1/2, which equals 3 over 2. And from the 3 points, this is 15. From the 3 points, you can tell that g of -3 is the largest, so this is your answer. So max value at g of -3. So part C, find the average rate of change of g of x on the closed interval of -3 to 7. So the average rate is f of b minus f of a over b minus a. So that would be your endpoints, so -3 and 7. So this would be a, and this would be b. So f of 7 minus, no, it would be g, I'm sorry, because it is g. -3 over 7 minus -3. And you would use the points you found in b to plug it in. So its points would be (3 over 2) minus 15 over 2 over 10, which equals -12 over 2 over 10. And that's your answer. And for D, find the average rate of change of g prime of x on the interval -3x to 7. Does the mean value theorem applied on the interval -3x to 7 guarantee a value of c for -3 c 7 such that g second derivative of c is equal to this average rate of change y or y naught? Okay. So for the average rate of change for integrals is g prime of b minus g prime of a for b minus a. So again, this is a and this is b. So at g prime of -3 minus g prime of 7 over, oops, sorry, switch that around, negative. It would be over 7 minus -3, which equals, so at g of 7 would be 1 minus -4 over 10, which gives us 1/2. 1/2. So it doesn't guarantee it that there's a value of c such that the g of the second derivative, c is equal to this average rate of change, because like there's just not enough info given. Alright.